All right, here we are with my wonderful students. Wonderful students. Crazy Victoria. I want you to know, Miss Victoria, your daughter is crazy as you are. I want you to know that. I want you to teach your mother good habits, okay? She can watch this video. All right? All right, excellent. Her mother is crazy. Now the whole world knows. Great sense of humor, your mother. Great sense of humor. Okay, now, can you just give that to me, that paper? We're going to do a problem that's a little confusing, especially for a 7th grader, but it's not going to be bad. It's going to be easy. Okay? Yeah? Okay. The answer will be obvious. Believe me. When I finish this, you'll say, not a problem. Okay? All right. Now, it says on page 41 of chapter 4, it says, number 19. Okay, number 19. It has 3 isotopes of sulfur. What would be the atomic number of all 3 isotopes? What would be the atomic number of all 3 isotopes? This is not a trick question. I'll give you a hint. Sulfur. No, that's the symbol. That's not the atomic number. On page 41 of the Atomic Structure Chapter Review, number 19. It says extra practice. Do you see it now? So what would the atomic number of all 3 isotopes of sulfur be? You guys don't remember things from the beginning of the year? It's a little scary, okay? It's been a while since we did it, maybe. It's the number of what? It's the same as the number of what? The atomic number is the same as the number of protons. Very good. And how many protons does sulfur have? 16. Excellent. Now, what's an isotope? There are 3 isotopes of sulfur based on the different number of... How do you know that? That's marriage. She's wonderful. God bless Ethiopia. Absolutely. 3 points for the Ethiopian team from Gryffindor, okay? All right? That's right. The number of neutrons. It's based on a different number of neutrons. So, we have 3 isotopes. You can say, how does this sound? Does this sound good? Variations. 3 variations, right? 3 variations of sulfur. Is that a little bit more understandable than say the word isotope? Doesn't the word isotope almost sound dangerous? How many people think the word isotope sounds terribly dangerous? Raise your hand. Half the class is raising their hand. All right, my 2 new students from South Korea are raising their hand. So even in another language, I mean, they don't, I mean, their English is pretty good, but the word isotope is scary. How many people think the word isotope is scary? That's another way of saying it. They're all raising their hand, yeah? Yeah? Yeah. Well, it's not. It's just based on different numbers of neutrons. That's all it is. There can be scary isotopes. There can be scary elements. If somebody says here's a handful of uranium, I don't care what kind of uranium it is, that would scare me. Or here's a handful of polonium, that would scare me. Do you know that in New Jersey, I don't know about other states or other countries, but you have to have your basement tested for radon. Yeah, because if there's too much radon, not good. Give you terrible cancers, lung cancers and things like that. Terrible stuff. Radioactive radon. Yeah. Radium, radioactive. Yeah. I almost can't continue this video. She said the P word. Plutonium. Scary. Yeah, it's very scary. But the word isotope is not a scary word. It's okay. It's okay. Variation. Does that sound better?
Yeah.
a variation of the element. All right, so we'll use variation, but we'll mean isotope. Is that okay? All right, so there's three. You have sulfur, sulfur, sulfur. Now, subscript, you know what that is, a subscript? Yeah. So they're all 16. The subscript is actually the atomic number, right? Here's the element, and you have a superscript and a subscript. This is the mass number, and this is the atomic number. You see that? Okay, now, if it's based on the number of neutrons, then the atomic masses, the mass numbers would all be different, right? Yes or no? Yes? Okay, now, this is a little confusing, believe me, but I'm going to write down the three mass numbers, okay? 32, 33, and 34. Is that okay? Now, what they do is, they do, when they talk about an isotope, they oftentimes will give you a decimal, right? Where we know that mass numbers, a mass number is just the number of protons and neutrons, right? Sometimes when they talk about isotopes, they actually give you a decimal, okay? And that's problem number 23, yes? Yes? But problem number 19 becomes before problem number 23. So we're going to do problem number 19, and I'm going to use mass numbers to do this, okay? Yes or no? Now, we're going to base this on, even though they do percentages of this, we're going to say this like this. We're going to go, this is the dominant one. We're going to say this is 90%. 90% of sulfur, 90% of sulfur is absolutely, positively, everyday, normal. If you want to write sulfur just with the mass number, this is how they do it. They say sulfur 32. Sulfur 32, that's by saying, that's like really fancy. Sulfur has a mass number of 32, and you say, well, which isotope is that? Is that sulfur 32, sulfur 33, or sulfur 34? You'll sound very, very intelligent. You want me to give you an example? U-235, what does that mean? U-235. Uranium isotope with a mass number of 235, right? Yes? U-238. That's uranium with a mass number of 238, right? Right? The dominant isotope is 238. The minor isotope, the radioactive, the terrible one that makes the bomb, is the 235, right? So this is going to be S33 and S34, okay? Yes? We're going to say that this is 8% and this is 2%. We're completely making up these percentages. Is that okay? Completely making them up. Completely. We're fibbing. We're just making this up. I just want to make a point. Okay? Yes? Yes? Okay. So we're going to say that if you take any 100 atoms, let's say, randomly, right? 100 random atoms, okay? And you say, okay, 90% of those is going to be uranium-232. How many atoms would that be of uranium-232? 90% of 100 is? They're very tired. This is the end of the day. These guys are very bright, and they're just kind of like, Greta, what is 90% of 100? 90% of 100. 90, right? Right? Absolutely correct. You see now? Does everybody see how 90% of 100 is 90? Whoa. Whoa. How do you do that? 0.9 times 100 is 90, right? A little late in the day, isn't it, Alyssa? Alyssa's like this. Okay? He looks a little tired, okay? So 90% of 100 is 90 atoms. of that isotope. This is going to be how many of this isotope?
8.
How many?
8.
What'd you say?
8.
Excellent. Nice recovery. Excellent. 8 atoms of sulfur 33. You want to sound intelligent? You ready?
Yes.
All right. All right, this is for Alyssa. Alyssa, 8 atoms of which isotope? S 33, right? So say it again, say it.
S33.
Yeah, you sound like a chemist. You sound very intelligent. Excellent. And this is going to be 2, right? Now let's add up the total mass of these 100 atoms. Is that okay? Can we do that? Do you know enough math to do that? Have you ever done averages before?
Yes.
Yes? So I want to find the total mass of that, right? How many atoms make up 32? Take out your